In today's video, we are going to go over the Practice Benchmark 3 Part 1, which is 12 multiple choice questions. All right, so let's dive right into it. Number one, it gives us a graph, and it looks like it's a piecewise function with a couple different pieces. We have this piece, and this piece. So it says for which interval of x is the function increasing and linear. So probably easier to see whether it's linear or not, right? The linear portions are the straight lines, right? These are the two linear right here. This is going in a straight line as well as this one. Now, which one is increasing? Remember, increasing functions go up and right. So this portion's going up and right. This is going down and right. So this is decreasing. This is increasing. So this is the portion we are looking. This is our answer pretty much. And now what intervals is it in between? It's in between 4 and 8, right? It's going up between 4 and 8. So that is my answer right there. The next one, it says, at the beginning of spring, Ethan planted a small sunflower in his backyard. The graph below represents the sunflower's height in inches after X weeks. What's the constant rate of change? So we take a look at our graph. All right, so we take a look at the rise over run. It's going up 1 over 2 boxes, but the slope is not 1 over 2. You have to look at the intervals on the y-axis and on the x-axis. This is going up, actually, 16 to 18.5 goes up 2.5 over 1. So 2.5 divided by 1 is 2.5. So you got to be careful. You can't just count the boxes. You have to look at the intervals on the y and the x to determine your rise over run. So it's 2.5 over 1, which is 2.5. The next one, which transformation is being done to accomplish what is diagrammed below? All right, so we have triangle ABC, and it looks like it's being translated, right? It's slid down and right to A prime, B prime, C prime, right? If it was reflected, it would be flipped. If it was rotated, it would be turned, right? So this is just translated down and right. So that is a translation. All right, not a dilation. Dilation makes something bigger or smaller. All right, which graph represents a function? Now remember, a function passes the vertical line test. So wherever I draw a vertical line, it only can intercept one spot. So this would not be a choice right here, right? Because you could even look at the y-axis. Look at the y-axis, intercepts more than one spot of the function where that vertical line is. So that's not it. Okay, this one, if I draw a vertical line here, it intersects at 2 spots. This is not your answer. Okay, this one, if I draw a vertical line here, same thing. Not this one. Process elimination should be this one. And yes, no matter where you draw a vertical line on this graph, it's always going to intercept one spot, right? You're not going to have any repeating x values. So this is your answer. All right, number 5, it says the 4 tables below show relationships in which x values represent inputs and the y values represent the corresponding outputs. Which table represents a relationship that's not a function? Function, not a function. Different than linear, okay, not a function. So whether we're determining something is a function or not, we're looking for repeating x values. If any of the x values repeat, it is not a function. All right, now if we look at this one, none of the x values repeat. So this is a function, but remember, we're looking for not a function, so this is not it. All right, right here, again, none of the x values repeat. This is a function. None of the x values repeat. This is a function. This one, the x values do repeat here and here. So it is not a function. So this is the only non-function out of the 4 choices we looked at. All right. So again, Functions have all different x values. Non-functions have repeating x values. Number 6, two functions are described below. Function A, the equation y equals 150x plus 100 represents the relationship between the number of hours x a plumber works and the total charge y to a customer. All right. Function B, a plumber charges customers a base amount of $150 and also an amount of $100 per hour for a total charge y to a customer. Which statement correctly compares the relationship between function A to function B? So first choice is function B has both a greater rate of change and a greater initial value. So first of all, let's write out and determine what our rate of change and the initial values are. So there should be a show your work. There it is. Okay, so function A. So with function A, all right, we have the equation y equals 150x plus 100, right? Remember, the 150, that is your rate of change, and this is your initial value, right? The B value, where you start. Now for B, do a different color, do this one. Okay, let's determine the rate for B. So a plumber charges customers a base amount of $150. So that is your initial. So that is plus 150, right? So that's your initial amount. And your rate is $100 per hour. All right, so this one, the rate is 100. So it looks like A has a higher rate than B, but a smaller initial amount. All right, so is that one of our choices? Function A has a greater, we know it's not this one. Function A has a greater rate of change than function B, which it does, but the initial value for function A is less than the initial value for function B. And that's the case right here, right? 100 is less than 150. So that is my choice. Number 7, which transformations maintain congruence when being applied to geometric figures? So that means out of all of these transformations, which ones maintain congruence, means they stay the same size. All right, so a rotation, when you turn something, it still stays the same size. So we're going to click this one. Dilation, when you dilate something, it's going to make it bigger or smaller. So it's not going to maintain congruence, but it will create a similar figure, but not maintain congruence. So it's not this one. Translation, you're just moving it up, down, left, and right, like you saw in the graph above, right? This one right here. Yep. It still maintains the same size. You're just moving it. You're just sliding it. So that one maintains congruence. And a reflection does as well. Remember, a reflection just flips over a specific axis, X, Y, or over a line. So that maintains congruence as well. So dilation is the only one that does not maintain congruence because you make it bigger or smaller. All right. Number 8, linear function passes through the points -2, 4, and 2, 2. What is the rate of change? All right, so let's, we're going to have to show some work with this one. So we have -2, 4, and 2, 2. You can use the slope formula. Remember what the slope formula is? y2 minus y1 over x2 minus x1. All right, so my y2 is 2, right? Minus 4. 2 minus 4. And x2 minus x1, 2 minus -2. All right, So be careful with that. 2 minus 4 is negative 2. 2 minus negative 2 is positive 4. And then I can reduce that to negative 1/2. So be careful. Make sure you simplify your answer at the very end. And it's negative 1/2 right there. So just be careful. Remember, minus and negative is the same thing as adding a positive. So 2 minus negative 2 is positive 4. A line contains the points 3, 5, and 0, 4. What is the equation of the line? All right, let's show our work here. All right, again, let's find the m, right? Same thing as we did last time. Y2 minus y1, so 4 minus 5 over 0 minus 3. Which is negative 1 over negative 3, which is 1/3. So we take a look at our answers, and there is only one equation that has a slope of 1/3. It's right here, right? And we could double check because the y-intercept is 4, and 0, 4, this point right here, 0, 4 is on the grid, so that is the y-intercept. So that is your choice. All right. So sometimes you might not have to go all the way and figure out the entire problem for figuring out the y-intercept. You can just find the slope. Number 10, it says a line is graphed on the coordinate plane shown below. What is the equational line? So it starts at negative 4, right? That's your y-intercept. I should say it starts. That's your y-intercept. And it goes up to right 3. So rise over run up to right 3. And it starts at negative 4, which is this first choice right here, right? Goes up to right 3. And the y-intercept is negative 4. Number 11, the set of ordered pairs below represents a relation that is a function. Which point, when added to the set, would form a relation that is not a function? Keyword not. Okay. So when we have, again, something that is not a function, we have repeating x values. Okay, so what is going to create a repeated x value scenario? So that means if I have a negative 2, a negative 3, or a 4 in my x values, that is going to make it not a function. So this one right here, 5, that's going to make it a function. So it's not this one. 3, right? If I added this point at the end here, right, 3 and the 3's would make it not a function because you have a repeating inputs. So it would be that, right? Zeros wouldn't work, right? 2's wouldn't work because the 2 and negative 2 are different. So your answer is 3, 6, right? If I put this at the end of this relation, it would not make it a function. And the last one, it says rectangle A prime, B prime, C prime, D prime is similar to rectangle A, B, C, D as shown in the coordinate plane, and a double prime, B double prime, C double prime, D double prime is similar to the previous prime figure shown in the coordinate plane below. Which sequence of transformations maps ABCD onto the double prime figure? So let's zoom in and see. Oop, too much maybe. That's okay. ABCD, that's our original figure. And it looks like here. And look at the letters. Just be careful when you look at the letters, because it could be slid down, but it's really not. It's not translated down. The letters are flipped, right? We have AB on top here and AB on the bottom here. So this looks like it's reflected over the x-axis. So it's reflected over the x-axis, and then it looks like it's rotated, right? This is on the right, CB is on the right, and then CB is on the top. So it looks like it's reflected over the x-axis and then rotated 90 degrees counterclockwise. Let's see if that's a choice. We know it's definitely over the x-axis. Reflection over the x-axis followed by a rotation of 90 degrees counterclockwise. There is my answer right there. So you got to be careful when you're looking at the orientation of the letters, right? The AB starts up top, then goes on the bottom, and then it goes to the right. So it's being reflected and then rotated. All right. So that's it for all of these questions. If you have any other further questions, feel free to reach out to me, and best of luck.